Okay. So, we're talking about the rational zero test. As I mentioned yesterday, right, that factoring is kind of the overall goal, what we're trying to do, different polynomials, being able to factor, okay, adding to our toolbox, okay, our repertoire, different tools we can use to help factor polynomials and things to get to zeros. And of course, we kind of introduced yesterday, or not introduced, reintroduced, right, reviewed long division and synthetic division, both of which can pretty much be used to factor any polynomial, right? Anything you come across. But the catch for those two tools, long division and synthetic division, is that you need to actually know a zero ahead of time, or you'll be guessing and checking all the different, factors. Okay. So, is there some way we can help, fix this? And we're going to come up with, we're going to use something called the rational zero test. Now, this is still not perfect. Okay, this thing that we're going to be using today only helps us find rational zeros, or that is, it helps us find just a list of possible rational zeros, and so we still would have to guess and check answers here to see what works. Okay, and you'll see what I mean in just a second here. And of course, if our polynomial has no rational zeros, then this test is useless to us. But I promise I'm not going to do anything mean like that to you. Okay. So again, the rational zero test gives us a list of possible rational zeros. Okay, for a given polynomial. And so we'll just dive right in then to kind of an example, and then I'll show you how the rational zero test works. So the question we want to be able to answer here is, what are the possible rational zeros of, I'll give a polynomial here, let's say x cubed plus 2x squared minus 4x plus 8. Oh, minus 8, doggone it. Okay. So actually, you may notice that we can do what here with this polynomial? It factors by grouping, all right? So this is, an example where we really don't need to use the rational zeros. We can just factor by grouping here and see what the different zeros would be. But let's use the test here, and then we'll see if at least it would agree with the factoring by grouping stuff. Okay. So to apply the rational zeros test, all right, what we need to do is first of all identify two pieces of our rational zero test, or to identify two pieces of our polynomial. Sorry, to then use the rational zero test. Okay. So part number one is going to be the lead coefficient here, which is what? It's going to be positive 1. Okay? And we're going to call that number, that's going to be Q. Okay? And then we have another piece of our polynomial that we're going to identify, if that's the constant. Okay. And we'll call that P. So again, P is the constant value of the polynomial. Okay. And then Q is the lead coefficient. And the rational zeros test says, okay, that the possible zeros, okay, the possible zeros will be equal to factors of P divided by factors of Q. Factors of P over factors of Q. So all those different factors of P over all those different factors of Q are all of the possible rational zeros. There's no other rational zeros. Okay, you will not be able to find another rational zero outside of those options. All right, so let's examine what those possible zeros could be. Right, so let's list out here. So the factors of P, and then we'll also put the factors of Q too, and I'll just put them on top of one another there. Okay, in kind of like a weird fraction. Okay. So what are the factors of P there? What divides -8 evenly? What can we divide 8 by? -8 by? 2, okay? Plus or minus 2 though, right? Because we could divide 8 by a +2 or a -2. What else? 1. Yep, it's always going to be there, right? What else? 4 and 8. There we go. The chorus joins in. There we go, okay? And so what about the factors of Q? Just 1, that's it. Yeah, plus or minus 1. Okay. So that's kind of like, you know, all the factors of P over all the factors of Q, which means then all of the possible rational zeros will be plus or minus 1 over 1, which is just 1, plus or minus 2 over 1, which is just 2, plus or minus 4 over 1, which is just 4, and then plus or minus 8 over 1, so plus or minus 8. So we have, you know, 8 possible zeros there. 8 possible zeros. Okay. And so we ask, so there's all the possible rational zeros. Okay, we kind of answered the question that we were looking at to answer there. But of course, let's take it one more step here, and let's just say, what are the rational zeros? Not just the possible ones. What are the actual? What are the rational zeros of x cubed plus 2x squared minus 4x minus 8? And so then how might we use this list of possible rational zeros in conjunction with our polynomial here to figure out whether they are actual rational zeros or not? Yeah, Sean? All right, absolutely. Yeah, so one way you can do this is just take turns substituting these things in, okay, for 0, plug them in for x, sorry, and then they should give us 0 if they work. Okay, so yep, that's one way to do it. So one option, plug in each possible 0 to see if the polynomial will equal 0. Okay, so that's one option. Any other ideas? What else can we do? Yeah, Lindsay? Use synthetic division, exactly right. Okay, so in fact, let's go ahead and do that just because plugging in, I feel like we're pretty good with substituting in values here, but since we just learned synthetic division, so use synthetic division to check. And of course, if we can use synthetic division to check, we can also use long division. But, you know, why use long division when we can use the more efficient synthetic division here? And it's because, you know, we're just, we can have our zeros and stuff. So use synthetic division to check the zeros. Okay, and so yeah, let's do that. All right. So Lindsay, pick a number. Not any number, but of course from the list there. 2. All right. Ooh, wise choice, Lindsay. Wise choice. All right. So 1, 2, -4, -8. All right. Put in your coefficients there. There's no need for placeholders. So we'll drop that down. Drop the 1 down. So 1 times 2, 2. 2 plus 2 is 4. 4 times 2 is 8. -4 and 8 is 4. 4 times 2 is 8, which is 0. Oh, good job, Lindsay. Excellent guess. All right. So, yes, we got a remainder of 0. That's awesome. All right. So 2 is a 0. Does that mean we shouldn't guess 2 again? No, 2 could still be another 0, right? We have like double 0 sometimes, right? Things that like occur more than once. And so that could be a possibility here. The nice thing about using synthetic division is that now at this point we have a couple options. Option 1 is this is a quadratic, so we could just take that x squared plus 4x plus 4 and see if it factors, which it does, right, to x plus 2 times x plus 2. Okay. Alternatively, which means then what are the zeros? What other 0 do we have besides the 2 that we just found there? What are other zeros that we have here? -2, right? These are the factors, right? And so then the zeros from these, though, the zeros, the thing that makes this thing 0 would be -2. So our zeros are 2 and -2. Okay, so we can just answer that up here now, I guess. X equals 2 and -2. And if you want to put -2 again, just because it does happen twice, that's fine. You don't need to, but there. Okay, so those are our three zeros, but really just 2 unique ones. Okay. So I said there's more than one option here. So option 1, you can once you get down to a quadratic, you can stop and just factor it. All right. Option 2, if you look at this, we now only have a 1 leading coefficient, but now we have a 4 as our constant, which means our rational 0 test has now reduced the number of zeros possible, right? Whereas before, in the earlier polynomial, right, we had our p was 8 and our q was 1. That indicated then we would have a possible rational 0 of 8. But now our p's and q's have changed, well, just the p has changed, so 4, we no longer have 8 as an option, right? Now we're looking at plus or minus 4, plus or minus 2, plus or minus 1. So that's another thing, too. You can always, like, once you kind of factor or take out one 0, you can then, kind of regroup and see if, your zeros list has changed, like reduced in size or anything like that, too. So that's another option as well. All right. So, lots of choices there. But of course, we could have also just factored this thing by grouping and ignored this completely. But the good news, right, is that you have options. And should you kind of forget factor by grouping or whatever, or if you can go down different paths here and still arrive at the same answer, which is nice. Okay. So questions on any of that? We'll try another one here. All good? All right. Let's try another one then. All right. All right, so now we're going to find the rational roots of x to the 4th plus 2x cubed plus x squared plus 8x minus 12. Okay, so let's see here. So Emma, what is our p going to be here? -12, and then q is 1. Okay, which is nice. So then, over here on the side, I'll list the possible zeros. So notice here the directions say just find the rational roots. So I'm going to list out the possible ones and then use that as a list to kind of pick and choose here. So I'll say possible zeros Alright, so we need all the factors of 12. So that's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Thankfully, that's all O plus or minus 1 there. Okay. And again, remember, it's factors of P over the factors of Q. Again, you know, just be careful not to mix that up, right? Q comes first, it's the lead coefficient, but it goes on the bottom. The factors of Q are on the bottom. P is the last number and when things are written in order, but again, it goes on top. All right. All right, so let's see here. Let's try 1. All right. And so then our synthetic coefficient here is 1, 2, 1, 8, negative 12. Okay. Or alternatively, you could plug 1 in and see if it works, right? That's also an idea too. Plug 1 in, see if it works. All right. So 1 times 1 is 1, 2 times 2 plus 1 is 3, 4, 4 times 1, 4, 8 and 4, 12, 12 times 1, 12, 0. Good guess, Mr. Whitman. All right. So at this point, right, we still have a 1 leading coefficient and a 12 as our, you know, constant, and so the P and the Q have not changed, so we would still need to pick, you know, from this possible list here. But it can be helpful also to kind of like pause real quick and just take a look, examine, you know, your answer here. You could proceed forward and just keep guessing and checking, that's fine. But it's not, you know, a bad idea to sometimes just stop and smell the roses here and see anything. So if that's our polynomial, what else could we do here besides pulling out factor by grouping? Yeah, so we can actually factor things by grouping at this point. Okay, was that factoring by grouping helpful? Yeah, we ended up with an x plus 3 and an x plus 3, so we have a common factor pull out there. Okay. All right, so we already know one of our rational roots, one of our zeros is x equals 1. What's another rational root that we have then? X equals negative 3. Right, because x plus 3 is one of the factors, and so therefore x minus 3, sorry, x equals negative 3 would be a 0 or a solution there. What about that x squared plus 4? What's that going to give us? A negative 4, which means that we have what kind of roots? Imaginary roots, right? X squared plus 4, if you set that equal to 0, you're going to move the 4 over, make it negative, so x squared equals negative 4. Square root of a negative is imaginary. So we're trying to find just the rational roots, and so there they are. Okay. All right, let me, I think I'm going to I'll do one more, and I'll have you guys try one. Yep, one more here, and I'll have you guys try one. Okay. So there's our polynomial. Same directions. Find the rational roots or find the rational zeros, right? Zeros and roots are synonymous. Okay, find the rational zeros, find the rational roots of that. Okay. So what is our P here? What's P? 0. Okay, our P would be 0. Okay. And what's our Q? 6. Okay, yep, 6. Okay, so if we list all of our possible zeros here, we're going to have plus or minus, okay, it's just 0 in the numerator there because you currently have a positive or negative 0. And then the q is going to be plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. I did it backwards order, I don't know why. There it is. So, wow, that really makes it easy. What's our only possible 0 here? 0. And that's because what could we do at the very start of this thing before I started using the rational roots test here? Yeah. There's an x, a GCF of an x here to factor out first. So again, you may use all the different tools that are at your disposal here, right? So for example, this one, if you look at it right away, like, oh, there's an x to factor out, then factor that x out first, right? Because once we take that x of 0 out, which I'll just go ahead and just factor it out. We could use, synthetic division there too if you wanted to. You should arrive at the same result here. Okay, so now we know that x equals 0 is one of the zeros. Okay, so write rational zeros here. So x equals 0, right? But then you also want to take care of this thing. And now that I factor that x out, what's my new p-value? 8. Yeah, now the new p-value there is 8. Okay, and then the new q-value is still, well, not new q-value, it's still 6. Which means now the possible zeros, okay, possible rational zeros, are going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8 over plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay. So, yeesh. So if we were to list, bless you, list of possible zeros, I know I'm like writing a ton over here on the side, but wow, what a great list this is going to be here. Let's just see what we can put together. So again, factoring that x out, right, yielded a new p and q value. We had to reevaluate our possible rational zeros. Okay, it was glaringly obvious here that 0 was going to be one of the zeros, but that wasn't the only one because now we have a new polynomial to deal with. That's our p of 8 and our q of 6. So we're going to have all those factors of p, 1, 2, 4, and 8, plus or minus, and then q factors 1, 2, 3, and 6. And so all the different combinations here are possible zeros. So for example, we could have plus or minus 1. Plus or minus 2, plus or minus 4, plus or minus 8, right? Because 1 over 1, 2 over 1, 4 over 1, 8 over 1. But then we also have to put these things over 2. So 1 over 2, that is a new possibility, 1/2, right? 2 over 2, I don't need to write that one again because we already have the plus or minus 1, right? So 1 over 2 we need to do because we don't have 1/2, but 2 over 2, don't need it. 4 over 2 I also don't need, I already have 2. And 8 over 2 I don't need because we already have plus or minus 4. But then let's see the next one, 1 over 3. And then 2 over 3 are also, and then 4 over 3, and then the 8 over the 3. Okay? So again, the 1 over the 3, the 2 over the 3, the 4 over the 3, the 8 over the 3. All possible zeros. And then lastly, we'll have the 6. So 1 over 6. 2 over 6, do I need to write that one down? No, because it's 1/3, right? So we got that one. How about 4 over 6? Nope, because I have 2/3. And what about 8 over 6? That implies to 4/3. I've got that one already, so we're good there. Okay, so wow, look at that list. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but of course times 2, 20. So there's only 20 possible things that you could guess there, right? Just 20 things. All right. So let's guess 1/2, and we'll put in the 6, 17, negative 26, and 8 there. Let's see if that 1/2 works. Okay, and of course you could plug 1/2 in for the x values there, see if it gives you 0, right? That's one option there. can also use synthetic division here, so let's see if it helps. Let's see, 6 times 1/2 is 3. 3 and 17 is 20. Half of 20, ooh, that's 10. Let's see here, 10 and negative 26, negative 16. Half of negative 16 is, oh, wow, what a good guess, Mr. Whitmire. Well done. Well done. Okay. And so at this point, we're now at a quadratic, so I could just do 6x squared plus 20x minus 16. We can divide out a 2. Okay, and then just try and factor this thing. So let's see here, we're going to have a 3x and x. You can use like the magic x thing if you want to use that. You know, I'm just going to guess and check it here because why not? I think it's plus 4 and there you go. Yep, 3x minus 2 and x plus 4. Okay, and so that means we also get then x is 2/3 is going to be a 0 and x equals negative 4. Okay, so we have the 2 zeros here from the quadratic, so I'll put that up here with my list. And then I also have a 0 from the synthetic division, that 1/2. Okay, and there are all of our rational zeros. So that's our final answer. Yes, Devin, question.
I know to stop there, like how do you know that none of the other numbers work?
Ah, good question, good question, good question. So, how do we know to stop there? Well, at this point, we've taken our original polynomial, we factored out an x, then we took out another factor that gives us a 0 of 1/2, which leaves us with this quadratic. And the quadratic we were able to simplify down to just this. And so at this point, there's nothing left to divide out, right? So we're done. Another kind of hint too is that the degree of a polynomial here, so in this case 4, the degree kind of indicates the maximum number of rational zeros that you can have too. So at most we'll have 4 rational zeros there because of the degree. Okay, so does that make sense to you? Good question, very good question. So that's how we know we can stop. We just factor it all out. So another thing, okay, this is helpful to see. So that means this 6x to the 4th plus 17x cubed minus 26x squared plus 8x, right? We can factor this thing too. Let's see. So I guess I can, do it this way. I think. Yes. So we know that it's going to be equal to the 3x minus 2. Times that x plus 4 times x, right, because there was an x in there we were able to factor out, and then I think there's one, oh gosh, that's a weird place to put the x, but I put it there. So, and then the other thing, that 1/2, we got to be careful here. So this 1/2 with the synthetic division, that can mean a lot of different things, okay? That only means that our 0, we have a 0 at 1/2. So that means we could have a factor of x minus 1/2, right, we could. But it could also mean that we have a factor of 2x minus 1. Okay, and so you have to kind of be careful about writing that down here. That 1/2, just because that works in synthetic division, that could mean that the factor is 2x minus 1, right? That would give us a 0 of 1/2. But it could also mean that the factor is x minus 1/2, or again, any other combination of things here. So we have to kind of be careful. We know that these two things are factors because, well, we were able to factor the quadratic to get those two things, and we were able to pull the x out. So then it's really a question mark here about what that thing could be. I'm going to guess it is the 2x minus 1, okay, but we're not really sure. So I want to be a little cautious there when it comes to doing that synthetic division and all that, okay? But I think it would be the 2x minus 1 there. I think it would be, okay? You can check to see if 2x minus 1 actually works by actually doing the long division there with that, I guess. Anyway. Questions on any of that? Gosh, that's a lot. Okay, let me give you one to try. So y'all try this one here. Okay, and I want you to find all rational zeros of x cubed minus 6x squared plus 11x minus 6. And if you get done that one, you're like waiting around. I'll just give you another one here on the board as well. And again, just find the rational roots of of x cubed plus 7x squared minus 38x plus 24. Possible those would be actual zeros then, so like 3 and 1. Yep, no, so I mean, again, once you've taken, like, once you have a 2 as a 0, and you're ending with this, then when you have this thing, you just, all you need to do is find the zeros of this now, which when you factor it, will give you these, right? So it's going to be plus positive 3 and positive 1 then, right? That's right. So the zeros. So the factors are x minus 1 plus 1. The zeros would be 2 and opposite. And it's very easy, you know, subtle differences. Okay, so once you've got 2 to work here, you won't then need to worry about the zeros of this. You don't need to like do another synthetic division. Once you turn the quadratic, you just factor the zeros. See, you get 1, 2, and 3. If you did this, so you kind of like did it 2 different ways about ended with the same answers, right? 1, 2, 3, and you got 1, 3, 2. You got the same information. So you have the same. All you have to do is just go down one of these paths here, and you get the same answers either way. Does that make sense? Once you know that quadratic, you just factor the quadratic into there that way. Yes, yes, there is that, yeah. But I don't ever show that. Because I think I learned that once at one point, but I just forgot about it. So. But yes, you may use that. There are other rules too.
I don't remember what it is now.
It has to be. Go ahead.
It's like, I don't know, you know, if it's 0, then you know that, like, anything higher than, I don't know, like, I just really like that.
Yeah.
What sort of,
No, and there's also something with, like, how many times it changes signs, too. Did you ever learn something about that, too? There's something like, okay, well, it positive, and then switches again, so, like, that indicates something as well, and all that other stuff. It's like, it's kind of like your division, or your, like, division rules, right? It ends with an even number, the rules are like 2, right? It ends with a 5 or 0, like those kind of, like, so, like, there are, like, rules like that to help you, and so, yeah, so if you want to, like, look those up or something like that, use those, feel free, right? Because, yes, there is, and I guess I should know these things, but, yeah. They're helpful, not necessary, because these lists can get out of control sometimes. All right. So let's go to someone who's here. Megan, what'd you get for your answers here?
I got 1, 3, and 2.
1, 2, 3. That's right, just like the count. There it is. Okay, so The 3 and 2's there. Alright. I got 1, 3, and 2 as well. It's more fun to say it 1, 2, 3 like that. Alright. Questions on that one? Okay. Again, once you get down to a quadratic, just try and factor that quadratic, right? So let's look at this other one that I was talking about. We wanted to find the zeros of, and what was it, x cubed plus 7x squared, minus 38x plus 24. Okay. Was anyone able to find a zero for this thing? That worked? Yeah.
3 works.
Andrew says 3 works. Let's try it. 1, 7, negative 38, 24. Drop the 1 down. 1 times 3 is 3. 7, 3, 10. 10 times 3, 30. Negative 8, negative 24, 0. It does work. And we end up with x squared plus 10x minus 8. Okay. So we know that our 0 is 3. Okay. But let's say our directions here were not just to find the rational zeros like all the other directions. Let's say directions here were to find the real zeros. Okay, so now we have to think, ooh, I hate number systems, but I'm going to try and remember this anyway. Rational numbers are numbers that can be written as fractions. Okay, fractions of integers. So for example, which ends up being like all of your like repeating decimals or your terminating decimals. All right. So rational numbers do not include irrational numbers, which are like square roots of, things that aren't perfect squares, like square root of 3, so for example, pi also is irrational, right? So real numbers include both the rationals and the irrationals. So we have a rational zero here of 3, but are there any irrational zeros here? And if so, how could we find them? So does this thing factor? Does x squared plus 10x minus 8, does that factor? No. So what can we do to maybe find some irrational zeros here? Quadratic formula. Exactly right. X equals, you thought it was gone, but here it is again. Negative 10 plus or minus the square root of b squared minus 4 times a times c. All over 2a, which is just going to be a 2. Well, I guess I'll put the 1 in just for the sake there. Okay. So, several of us here at this minus 4ac part had some mistake quiz, right? It's a minus 4, bless you, minus 4 times 1 times negative 8. That's going to be a pos 32. Okay. Negative 10 plus or minus the square root of 132 over 2. That's a pos 32 plus 100. Okay. So it's your 132 most certainly divides by 4. That's all, though. So we'll say that's negative 10 plus or minus 2 square root of 33. Yep. All over 2. And again, we could stop there or we could simplify. So why not? We're here, right? We'll be done after this, I promise. So we'll just break up the plus or minus there. Negative 10 over 2, 2 root 33 over 2. And now we can simplify to negative 5 plus or minus square root of 33. So those are our other 2 zeros. Okay. And so we know we're done, right? We got 3 zeros, there's a degree of 3, so it's like done, done, done. Of course, there could be situations where you'll only get like 1 0, okay? And then that means you might have some, like you could also have imaginary 0 too. Of course, we're going to ignore any imaginary solutions, okay? Keeping it real. So that's just beware your directions, right? If it's asking for rational zeros, you're only going to include, integers and your fractions, okay? But if it's real, then you want to also include these square roots. But of course, the only way I can really get you to do those square roots is by getting it down to a quadratic and then having to use the quadratic formula. Okay, so that's that. All right. Any questions on anything here? Else I'll give you the assignment. All right. So your assignment, page 176. Numbers 16 and 21 to 29 odds. Okay? So let's back open those books and get started on that assignment. A million years ago. That's okay, I know.